Hello, notes for 5.2 bisectors of bisectors of triangles, and there's two kinds of bisectors. This reads, since a triangle has three sides, it has three perpendicular bisectors. That's the first type, perpendicular bisectors. When you construct the perpendicular bisectors, you find that they have an interesting property. So we're talking about perpendicular bisectors first. When three or more lines intersect at one point, the lines are said to be concurrent. Three lines intersect, one point, the three lines are concurrent. The point of concurrency is the point where they intersect. In the construction, you saw that the three perpendicular bisectors of a triangle are concurrent. Concurrent. Don't confuse that with the word congruent. This point of concurrency is called the circumcenter of the triangle. Circumcenter. So, with a perpendicular bisector, a triangle has three of them. If you look at this theorem, I will draw in black the three perpendicular bisectors. They're in red now. It's this one, there's the second one, and there's the third one. Perpendicular bisectors. Notice the tick marks and notice the 90-degree angles. The theorem says this right here, that PA equals PB and it also equals PC. So from this point in the middle, with that red point is called the circumcenter. If I measure out to each vertex or to each angle, those three red marks that I just made are congruent. They're equal. The perpendicular bisectors themselves, what I have written in black, are not equal. Only from the circumcenter to the vertex, or to the vertices, are equal. With that said, the circumcenter can be inside the triangle, outside the triangle, or on the triangle. What does that mean? If the triangle is acute, the circumcenter, right there, will be inside the triangle. If it's an obtuse triangle, the circumcenter is outside the triangle. And the third possibility, if it's a right triangle, it lies on one of the sides. It's on the triangle. The next thing to show you is the circumcenter of triangle ABC is the center of its circumscribed circle. In other words, this P is the center of this circle. Notice it intersects at each of the three vertices. That vocab word is called circumscribed. We're going to have another word in a minute called inscribed as opposed to circumscribed. Well, look at this example. It says DG, EG, and FG are the perpendicular bisectors of triangle A, B, and C. So let me draw those in blue. This is a perpendicular bisector. This is a perpendicular bisector. And that's a perpendicular bisector. Perpendicular bisectors are not congruent. This segment, and that segment would be congruent. But also, the sides are split in half because it's a perpendicular bisector. So this half would equal this half. And this half would equal that half. And let's do 4 tick marks. 1, 2, 3, 4. 1, 2, 3, 4. So everything is marked. My directions say find GC. So find that length. From G to C looks like it's going to be the same That's that right there. Notice the little line there. 13.4. And that's my answer. 13.4. So I can put 13.4 onto that one, but also don't forget this one here is also 13.4. Take a look at the next one. This time I want to find GM, find that length. It says MZ is a perpendicular bisector. So let me draw in the perpendicular bisectors. Looks like that's a perpendicular bisector. That one would be, and that one would be. Well, GM, which is this length right there, would be the same as 14.5. Because if the right side is 14.5, the left side is also 14.5. So GM would equal 14.5. Look at the next example. It says this time to find GK. And it says KZ is a perpendicular bisector. Let's highlight all my perpendicular bisectors. KZ is this one in red. LZ and MZ. There's my three perpendicular bisectors, which means to the vertices are congruent. Well, notice that from G to Z, 19.9. So what would be from G to K? Oops, I don't need that. Let me erase that. I don't need this one. I want to show that this part right here is 18.6. That means from G to K would also be 18.6. Because that side is split in half. It's a bisector. Let's do another one. Find JZ. From J to Z, now it would be this length right here. That's what I'm trying to find. Well, it would be the same as this length and be the same as this length. Well, notice this one is 19.9. That means that all of them are 19.9. So JZ is 19.9. Well, if I'm given this problem, find the circumcenter of triangle HJK with vertices 0, 0. That's that point right here. And J is 10, 0, so it's over here. And K is 0, 6. And you should notice that's a right triangle. Well, if you look back at the third slide, where is the circumcenter of a right triangle? It's on the triangle itself. So if I draw in my three perpendicular bisectors, well, if you notice, it goes from 0 to 6, so halfway is 3. And I just go straight across. And the bottom one goes from 0 to 10, so find 5, that's halfway. Just like that. So my circumcenter, and here's the third one, it'll be just like that. So my circumcenter is that point right there. It's on the triangle because it's a right triangle. Find the vertices, find the circumcenter. It looks like if I write that as an XY ordered pair, it would be over 5 and up 3. 5, 3 would be my circumcenter. All right, so that takes care of the first kind of bisector, perpendicular bisectors. I'm going to skip the next slide. And I want to talk now about the second kind of bisector. This reads, a triangle has 3 angles, so it has 3 angle bisectors. So number one is perpendicular bisectors. Now we're talking about angle bisectors. The angle bisectors of a triangle are also concurrent. This point of concurrency is the incenter. So the first one was circumcenter. Now the definition is incenter. Well, if you look at the theorem, I will highlight in black my angle bisectors. It's from A to P or P to A. It's that red mark, this red one, and that one. Again, in black are my angle bisectors. They split each angle in half. You need to remember the angle bisectors themselves are not congruent. This is what's congruent. From this point in the middle, called the incenter, out to each side, those three green marks would be congruent. So the angle bisectors themselves are not congruent. It's just from the incenter out to each side is what makes it congruent. Look at your next slide. Unlike the circumcenter, the incenter is always inside the triangle. It doesn't matter if you have an acute triangle, an obtuse triangle, or a right triangle. The incenter is always inside or in the interior of the triangle. The incenter is the center of the triangle. Inscribed circle. A circle inscribed in a polygon intersects each line that contains a side of the polygon at exactly one point. So basically we have some tangents. We have a tangent there, there, and there. So now the circle is inside the triangle. Before we had the word circumscribed and the circle was outside the triangle. So they're opposites here. All right, bear with me. I'm almost done. This one says MP and LP are angle bisectors. MP and LP. Let me highlight those in red. So this is an angle bisector, and this is an angle bisector. Find the distance from P to MN. Let's go ahead and draw that in. From P to MN would be a perpendicular like this. So what's the length of that blue? It would be the same as P to Q, which is 5. So my answer is 5. If I went ahead and drew it in down to here, like this, that answer would also be 5. So all three of those blue marks would be equal, 5. Look at the next one. MP and PL and LP are angle bisectors. Let me highlight those in blue this time. That's blue and that's blue. Find the measure of PMN. So I want to know, what would that angle measure be? PMN. Well, here's what you do. Remember the rule of 180. Well, it looks like I have this out here is 20. Then I have 50 right here. That's only half, because the other half would be another 50. So angle N, let's write this down, is 20. Angle L would be 50 plus 50, or 100. That gives me a total so far of 120. 100 plus 20. If I subtract that from 180, that gives me 60. If I split that in half, that gives me 30. So that means that this half is 30 and this half is 30. So my problem is, what's the measure of PMN? That answer would be 30. How do you know it's 30 and 30? Because it's an angle bisector. It splits the angle exactly in half. Let's try another one. This time I'm trying to find a length, not an angle measure. It says that QX and RX are angle bisectors. So QX, which is this one, I'll put it in red, and RX are angle bisectors. Find the distance from X to PQ. In other words, from X, I'll put it in blue, to PQ, what's that length going to be? It has to be the same length as this one, 19.2. All of those lengths would have to be the same. 19.2 would be that answer. One more. Talking about angle measures now. QX and RX are angle bisectors, so let's put those in blue. QX is an angle bisector. RX is an angle bisector. Find the measure of PQX. So I'm trying to find this measure right there. Find the measure of PQX. Well, I'm going to use the rule of 180. So let's start adding up the triangle here. Angle R, well, half of it is 12, so the other half would be 12. So let's write that down. Angle R is 12 plus 12, which is 24. Angle P is given to me as 52. So let's add those together. What's 52 and 24? 76. That means if I take 180 and I subtract 76, I get 104. That means that angle Q as a whole is 104. But I only want half of it. Well, half of 104 is 52. That means the measure of half, PQX, is 52, and that would be my final answer, 52. So remember, there's two kinds of bisectors, perpendicular bisector and angle bisector. Hey, thanks for watching.